Earth, our home world, travels around the sun with precision, locked into a gravitational dance that's lasted billions of years. We often imagine our planet moving alone through space, attended only by its single, familiar companion, the Moon. But in the vastness of near-Earth space, not everything is as it seems. There are objects that don't follow the usual rules, silent travelers whose paths are neither purely earthbound nor entirely independent. These are quasi-satellites, small celestial bodies that appear to orbit Earth, though they are not gravitationally bound to it in the same way as the Moon. And now, a new one has been discovered, 2025 PN7, a small, newly detected near-Earth asteroid with a peculiar orbital relationship to our planet. It moves not around Earth, but with it, tracing a delicate, spiraling path as both orbit the Sun in tandem. Its presence reminds us that even in our planetary backyard, the cosmos holds surprises, subtle, invisible companions following alongside us through space. To the untrained eye, a quasi-satellite might seem like a moon. It stays near Earth, loops around in the sky, and can linger for decades or even centuries. But its orbit tells a different story. A quasi-satellite doesn't orbit Earth in the traditional sense. Instead, it shares Earth's orbit around the Sun, traveling at nearly the same speed and distance, but weaving a complex, corkscrew-like path from our perspective. These objects are gravitationally bound to the Sun, not Earth. Yet Earth's gravity gently shapes their motion, nudging them into a co-orbital relationship. To an Earth-based observer, 2025 PN7 will appear to trace a looping pattern, sometimes ahead of Earth, sometimes behind, in a slow, graceful cycle that repeats over time. It's like a cosmic pas de deux, two dancers moving independently, but always remaining in each other's orbit. 2025 PN7 was first spotted by astronomers scanning the sky for near-Earth objects, part of an ongoing international effort to detect and track potentially hazardous asteroids. Using wide-field telescopes equipped with sensitive detectors, survey teams captured a faint point of light moving across the background stars. It didn't match the motion of known satellites or asteroids. Further observations over multiple nights revealed a curious orbital pattern, not a direct approach to Earth, but a path that echoed our own around the Sun. As data accumulated, the orbit became clearer. 2025 PN7 was not just near Earth. It was dancing with it. A newly identified quasi-satellite, likely just tens of meters wide, quietly traveling alongside our planet for years, possibly decades. Its discovery is a triumph of modern sky watching, a reminder that even the space close to Earth still contains mysteries waiting to be uncovered. 2025 PN7 is a small object, likely no more than 50 to 100 meters in diameter. It wouldn't stand out on a planetary scale, but its orbit makes it extraordinary. Its path is eccentric, tilted slightly relative to Earth's orbital plane, and nearly synchronous in period. From Earth's perspective, it seems to loop around us once a year, tracing teardrop-shaped orbits in the sky. But it never truly orbits Earth. Instead, it remains bound to the Sun, its loyalty split in a gravitational tug-of-war. As for its composition, we don't yet know. Spectral data is still being gathered. Is it a stony S-type asteroid, rich in silicate minerals? Or a darker, carbonaceous body, a fragment from the early solar system? Future observations will reveal more. For now, it remains a cosmic question mark, one that whispers of ancient collisions and uncharted orbital pathways. Quasi-satellites like 2025 PN7 are more than celestial curiosities. They are scientific treasures, natural testbeds for understanding orbital dynamics, gravitational interactions, and near-Earth object evolution. Because they remain close to Earth for extended periods, they are ideal candidates for study, both from Earth-based observatories and, potentially, future spacecraft missions. These objects may help explain how asteroids are temporarily captured by planets, how orbital resonances evolve over time, and how material moves through the inner solar system. Some may even be relics of ancient collisions, fragments of larger bodies that broke apart eons ago and now drift in the gravitational eddies of planetary motion. For planetary defense, quasi-satellites offer insight into how small bodies behave when near Earth. Valuable knowledge if we ever need to deflect or redirect a potential threat. The discovery of 2025 PN7 wouldn't have been possible just a few decades ago. Today's sky surveys, like those run by Pan-STARRS, the Catalina Sky Survey, or the upcoming Vera-C Rubin Observatory, are capable of scanning enormous sections of sky every night. They detect even the faintest motions against the star field, flagging thousands of moving objects for follow-up. Artificial intelligence now assists astronomers, sifting through massive datasets, identifying patterns, ruling out false detections, and refining orbits. Together, humans and machines chart the skies like never before, turning darkness into data and data into discovery. 2025 PN7's story is only beginning. Astronomers will now track it carefully, refining its orbit, estimating its mass, and modeling its long-term behavior. How long will it remain a quasi-satellite of Earth? Will it drift away in a few decades? Or will gravitational resonances keep it near us for centuries? Space agencies may also consider it a target for future missions. Its proximity, stable orbit, and scientific interest make it a potential candidate for a robotic flyby, or even sample return, like what we've done with Bennu and Ryugu. Studying such objects up close could teach us not only about orbital dynamics, but also about the early solar system, asteroid mining prospects, and Earth's own co-orbital history. 2025 PN7 is not the first quasi-satellite we've discovered. Others have come and gone, including 2003 YN-107, 2016 HO3, and 469,219 Kemoalawa. Some stay for decades, others for mere years, caught in temporary gravitational relationships before moving on. They are elusive, often small, and difficult to detect, but their numbers may be larger than we once thought. Each new find is a reminder that our solar system is teeming with motion, a sea of subtle, shifting orbits and unseen companions. We are not alone, even in near-Earth space. We are surrounded by silent travelers, moving with us, unknown and unnoticed until now. 2025 PN7 joins Earth not as a moon, not as a satellite, but as a cosmic fellow traveler, a quiet companion sharing our journey around the sun. Its discovery reaffirms a simple, profound truth. The closer we look, the more we find. The cosmos is not static. It is alive with motion, mystery, and meaning. As we peer deeper into the night, we uncover not just rocks and orbits, but stories. Stories of formation and fracture, of resonance and rhythm, of ancient chaos giving birth to celestial grace. And so, as 2025 PN7 spirals gently through space, we continue to watch, to wonder, and to listen. For in the quiet paths of small bodies, the universe speaks. And we are finally learning to understand.